On Friday, we talked about all the different properties. Today, we're going to take those properties and we're going to use those in a little bit different way to solve equations. And so today is going to be a little bit more familiar to us because we're going to actually solve an equation. We're going to get an answer of x equals whatever. And in a lot of these situations, we're going to get decimals for our answer, okay? And so that makes it a little bit more difficult to like check because we get an answer that is an approximate answer, not an exact answer. But we're just going to kind of, and there's a lot of variations of these log equations. A couple things that you're going to need to have a good grasp of is the exponential to log form, being able to do that. All of the log properties that we talked about on Friday, we're going to see those pop up from time to time today. And so there's going to be some different things that we're going to use. To start off with a real basic one. 2 raised to the x equals 40. One of the things that we're going to notice here that is a little bit different, as we've talked about as we've gone throughout this chapter, is that we have a variable in the exponent. Okay? When we have a variable in the exponent, that's different than things that we've ever seen before, maybe in Algebra 2 a little bit, but we can't just do our basic add, subtract, multiply, divide, whatever, and get x by itself. Our goal is still to get x by itself, but because we have a variable in the exponent, that makes things a little bit different. And it's not just a nice power of 2, right? If this was like an 8 right here, then we know 2 to the third is 8, and so that would be a nice, easy answer. But in this case, it's not a nice whole number answer. So we got to figure out what's x going to be. And we're going to leave our answer in decimal form most of the time. So I have like a 3-step process that we're going to go through when we solve this. Anytime we see a variable in the exponent like this, most of the time you can do these 3 steps and get to your answer. Okay? So the first step is log it. And what that means, we're going to log both sides. Whatever I do to one side, I got to do to the other. That's step 1. Okay? When I see that variable in the exponent, we're going to log it. Step 2, we're going to use that property that we talked about last week. When I have an exponent on a log, where can I move, or what can I do with that exponent? Move it to the front, okay? So just because it rhymes, we say frog it. So I'm going to say this exponent is going to jump over the log. The frog is going to jump over the log. So we're going to rewrite it as x times log 2. Over here, we don't have an exponent, so we're just going to leave it alone. So the only thing that we've done on step 2 is jumped the exponent out in front. So we got log it, frog it, and then our final step is to solve it. Because we have a multiplication sign right here, we're taking x times the log of 2, then to get x by itself, we're going to divide by the log of 2. Okay, when we put this into our calculator, most of your calculators, or some calculators at least, will put an automatic parenthesis here in front of the 40. When you hit log, they'll put a parenthesis in there. You need to close that off after the 40. Okay, so hit log 40, close the parenthesis, divide by the log of 2. So just practice putting this into your calculators, just so you kind of know the process, because everybody's calculator is going to be slightly different here. Okay, and what do we get? And let's go to the nearest, a lot of times we're going to round to 3 decimal places, so we're going to go to the nearest thousandth a lot of times. Anybody have it? Down? 5.322. Good. Okay, and this is the part I was talking about earlier. Like checking it, usually if we have an equation, we can check it and life's good and see if my answer works. Here, we're saying 2 raised to the 5.322 is 40. Well, it's not going to be exactly 40, okay? If I go to my calculator, okay, so anytime we have a variable in the exponent, that's going to be our 3 steps. Not all the problems today are going to be log and frog solve problems, but when we see that from here on out, the rest of the chapter, that's going to be the kind of process we're going to go back to, is to log and frog and solve it. You could also do that on one like this. E raised to the t equals 1,000. And you can do regular log here. If you wanted to do LOG, you could do that. But anytime I see an E, then our go-to is going to be to use the ln, because ln goes with E. And that just makes more sense to use ln here. But if you did log, it would work out the same way. So once again, we're going to log it, frog it, solve it. But instead of using LOG, we're going to use ln. Always use ln with the E. And I'll show you why it's helpful and easier to use ln here in just a second. Okay, second step is to jump the exponent in front of the log. So we go t times the ln of E equals the ln of 1,000. Here's why using ln is so much better here. Because if we had the ln of E, and we talked about this last week, the ln of E is really what? How much? Not. What's my base assumed to be here? E, right? So E to what power gets me to E? 1, okay? So ln of E is always 1, okay? That's something that we always want to keep in the back of our mind. That's why we use ln as opposed to log, because it's a lot easier here. So essentially, I can just get rid of the ln of E here, because it's really 1 times t, or just t, right? And so now I'm left with t equals the ln of 1,000. So now this one's really easy to put into our calculator, because all I got to do is take the ln of 1,000, and that's our answer. And that, once again, we're going to get a decimal answer. We won't get a decimal every single time, but a lot of our answers today will be decimals. Okay. This one's very similar to what we just did, except instead of just having a t in the exponent here, we have a 4t. So it's going to look very, very similar to one we just did. First step, because we have a variable in the exponent, immediately we're going to think log it, frog it, solve it. Because we have an E, we're going to log both sides. Just make sure you log both sides. We're going to jump the 4t over in front. And then once again, we use ln because the ln of E is really 1. So we can just eliminate the ln of E because that really becomes 1. And I still got to get t by itself, so we're going to divide by 4 on both sides. So we're going to take the ln of 200 and divide it by 4. Once again, when we put this one in, parentheses are critical here. Mainly because the calculator in most cases puts an automatic parenthesis there. And if it doesn't, I would still put the ln of 200 in parentheses myself, just so that I know that I'm taking the ln of 200 and then dividing by 4. Because if I did this, your calculator is going to do the division first, and then it's going to do the ln last. So we always want to do the ln of 200 and then divide by 4. Okay. So that's really, really important to how we put that in. All right, what do we get for our answer there? Everybody type it in? What'd you get, Jackson?
1.325.
Okay. Okay. I always use the approximate symbols because it is a rounded answer and it's not an exact answer. Okay. And it'll tell you what to round to, but a lot of the problems that we're going to do here, we're going to round to the nearest thousandth, and we're going to go to 3 decimal. It just gives us a more exact answer when we do that. Okay, I told you that most of the time when we have a variable in the exponent, we can do log or frog to solve it. There are a few exceptions to the rule, and I'm going to show you one of those here. And this one's probably going to be one of the harder ones that we do today. The reason why this one's different is because we have a variable on both sides in the exponent. We have 3 to the x and 2 to the x minus 1. The other thing that makes this one difficult is that my bases are different. Okay, base of 3 and a base of 2. If the two bases were the same, this problem would be a piece of cake. But because the bases are different, then that changes this completely. We got to find out what the value of x is here. Okay, so it's not going to be quite log or frog to solve it because we have a variable in the exponent on both sides. The first step is still going to be log it. And we're going to go back to regular log here because there's no e in the problem. If there's an e, use ln. If there's no e, just use regular log. Okay, first step's still the same. We logged it, right? Second step is still going to be the same. We're going to frog it. We're going to jump the x out in front. So those two steps are basically the same. Here's where it's different. Because we have a variable on both sides, we can't just solve it and divide by something. So here's where it gets a little bit more difficult. If I had x minus 1 times 8, if I had a problem like this, what would I do with the 8? Distribute it, right? Well, guess what? Log 2 is a number. It's just not a very nice number, right? It's a decimal. But we're going to distribute the log 2 just like we're going to distribute the 8. So I'm going to take the log of 2 times both of these expressions. There is no parenthesis or anything to do on the left-hand side, so we're just going to leave that alone for right now. X log 3. There's nothing to distribute there. Over here, we're going to say x log 2 minus, and then 1 times log 2 is just the log of 2. There's no reason to write 1 times log 2. Hey, if I had, and I'm just trying to draw comparisons to things that we're used to, if I had x's on either side of an equation, what would be the first thing I would want to do? I'd want to get the x's together, right? I want to put the x's on the same side as one another. Same thing here. I want to get the x's, the two expressions that have an x, on the same side as one another. So I got to move, the best thing to do would be to move this expression over here. And this is where it gets a little bit different, okay? We're going to say minus x log 2 to both sides. So we have x log 3 minus x log 2 equals, those are going to be gone now, negative log 2. we really can't combine these together because log 3 and log 2 are decimals, right? And we really can't combine them together because they are decimals. And we don't want to write a decimal answer here. But one thing we can do here is because they both have an x in common, we can take or factor an x out. So both of those terms have an x in common. So I'm going to take that x out of both of those terms. Okay, now we want to get x by itself, right? We're taking x times this whole expression, whatever that is. And we're going to eventually put it into our calculator because it is a decimal, but we'd like to keep it all together. What we don't want to do is we don't want to round 2 or 3 times in a problem. I don't want to change this to a decimal, change each one of these to a decimal, and round 2 or 3 different times. I don't want to round until the very end of the problem. So we want to leave everything in as a log until we get to the point where we want to put it into our calculator. So because we're taking x times this whole expression, we're going to divide by this whole expression at once. Okay, putting this one into your calculator is a little bit tricky because you got a lot of stuff going on here. When you put this in, it's probably going to give you parentheses. So close the parenthesis off on top. And then we're going to go division. I'm going to go ahead and open up a parenthesis myself here. And I'm going to do the log of 3, close it off, minus the log of 2, close it off, and then close off the whole denominator. Okay, parentheses are really, really big deal here. If we don't put it in just right, then it won't read it correctly, and your calculator will be doing the problem in a little bit different order. Okay, try putting that into your calculator. Okay, what do we get? You guys are a ball of fire today, man. Gee whiz. Everybody just kind of staring at me like, I don't want to say, Mr. Ruda. Okay, what'd you get?
Negative 1.7010. Something like that. 1.7 is the first two.
Okay, negative 1.7. What comes after the 7?
0.9.
0.9. And what's after the 9?
5.
5. So
So then I was bumping it up.
Yep.
So I wasn't like saying the other was 1, 0. I was saying 1.710.
there you go. That's it. You got it. Yeah, so you do got to kind of remember our rounding, okay? As silly as it is to say, like rounding is one of the biggest mistakes made sometimes on these problems is because we don't round correctly or whatever. But because that 9 had a 5 or more to the right of it, then we would round that up to be 10. Okay? Everybody good with the calculator on that one? Okay, and like I said, this probably right here would be as difficult as the problem we're going to do today. There's a lot of steps here. There's a lot of algebra involved here. A lot of different things we got to be able to do. But just try to equate it back to some things that we've seen or done before, and that'll kind of help you out. When I see the log of a number, like the log of 3, that's a number. Okay, it's not just 3, but it's the log of 3. But I can do anything else that I would normally do with it, like distribute and move it and things like that. Okay, so we got e to the x minus 6e to the negative x equals 1. Okay, this one's a little bit different. Yes, we see variables in the exponent, so we might think log it, frog it, solve it, but I'm just trying to show you a lot of different variations of different types of exponential equations or log equations. because they're all kind of related to one another. We can go from log to exponential and vice versa. So here, I kind of like equate this to like a quadratic equation. Even though obviously it's not a quadratic equation, but when we have a quadratic equation, we have x squared, and then we have an x, and then we have a constant. And that's kind of what we have here. And if I was going to solve a quadratic equation, what was the first thing that we always had to do?
Move everything to the same side.
Yep, move everything to the same side. Set it equal to 0, right? And because all three of these expressions are so different from one another, we have different exponents, we have different expressions. I'm going to move the 1 over. So I'm going to go e to the x minus 6e to the negative x minus 1 equals 0. Okay, and I also kind of equate this to a quadratic equation because we talked about a lot of different ways to solve this. The good thing is we're not going to factor it or anything like that, but what was our go-to whenever we solved a quadratic? What was the first method or the best way to solve? First thing we always look to. Let's put it in our calculator, right? And so let's do this. Let's put this into our calculator. And all of these, it's going to say solve. And whether it's quadratic or a cubic or no matter what type of equation it is, in this case it's a exponential because we have a variable in the exponent, we're still looking for where is this going to cross the x-axis? What solutions, what's going to be our solution? Okay, and that's one of those where, depending on your calculator, everybody, I mean, if you have Casio, you solve it one way. If you have TI, you got to go to the 0 function on your calculator, one of those solving features that we have, and use your left bound and right bound. Casios are a little bit easier to do on that one. You don't have to do the left bound and right bound. We've done that a lot of times for a lot of different types of graphs, and we can do that again here for exponential graphs as well. Find out where it crosses the x-axis at is a big one. Okay, anybody got questions on that one? Pretty nice that you can just use your calculator to get your solution there. Okay, so all of those, we had variables in the exponents in some shape or form, right? And so we talked about a lot of different ways that we could solve it. Log it, frog to solve it would be our go-to if we can do it, but if not, we have some other ways to get there if we have to. So now we're going to look at equations that have log in them to begin with. So these are going to be some log equations. The ones that we started with originally were exponential equations because they had a variable in the exponent. So now the problems that we're going to look at are going to be a log equation. And we're trying to figure out what x is going to be. And I told you last week that knowing the exponential rules is going to be huge. If I know those exponential rules and I can go from a log to an exponential or vice versa, then it's going to make life a whole lot easier for me, okay? And so what I can do here is just remember the circle rule. 5 raised to the 4th is equal to x. So I'm changing that from a log equation back into an exponential equation. And as I look at that, boom, it's basically solved, right? All I got to do now is just take 5 to the 4th power. And we're done. So by knowing that rule, makes that problem really, really easy. If I don't know that rule, that problem would become a little bit more difficult, right? Being able to go from a log to an exponential. If I have the ln of x equals -2, what's our base assumed to be? It's always e, right? Base of ln is always e. LOG is always base 10. if a base is not given to me. ln is always base e. So once again, this is really just knowing how to go from a log equation into an exponential equation, and it makes this problem much, much easier. E raised to the negative 2 is equal to x. If I can change that into an exponential equation, now x is by itself, so all I got to do is be able to put e to the negative 2 into my calculator. Obviously not a problem I'm going to expect you to do in your head, because e is not a number that we typically would deal with. Okay, e to the negative 2. What do we get?
0.135.
Okay. So it's going to be really important to know how to put things into your calculator and know where that E button's at and all those kind of things. Okay, here's another one. Log of 1/4 base 64 equals x. Okay, and I'm going to show you there's a couple of different ways that we can approach some of these. Okay, this one, obviously, you can do the same thing we've done on the last couple of problems. 64 raised to some power equals 1/4. Okay, and now that we see the variable and the exponent, now I could log a frog to solve it, right? And so you could go through that process if you wanted to. You can kind of see how these two are related, but probably the best way to do would just be to log a frog to solve it. So I'm going to log both sides. I'm going to kind of combine two steps into one here. I'm going to log it, and I'm going to go ahead and jump the exponent over in front of the log. So then it would just be the log of 1/4 divided by the log of 64. Okay. And we actually did problems like this last year. If you know the log and the base, then that's just the change of base formula that we did last week, right? And so you probably don't have to go through all of this work to get to where our answer would be. Log of 1/4 divided by the log of 64. That's just your change of base formula. And I know that some of you have a change of base button on your calculator. And so everybody's going to have a little bit different process to go through here. Okay, what do we get for this one? Okay. Just to kind of explain a little bit about what's going on here, just so you kind of understand why the negative 1/3 would make sense here. Negative exponents make me take the reciprocal. And then 64 to the 1/3 power is really the same as the cube root of 64. And the cube root of 64, we could put that in our calculator, is 4. Okay, 4 times 4 times 4 would get us back to 64. Okay, so just trying to get you to understand why the negative 1/3 would make sense here. Okay, using our exponent rules and all of that. All you got to do is be able to get to the negative 1/3 as your solution. But don't write this, because we can do this as a fraction. We would rather write it as a fraction. We don't want to write 0.3 repeating, right? So always try that math frac button in your calculator. If you see a number that's repeating over and over again, then I don't want to write it as a repeating decimal. I don't want to round it. I want to write it as a fraction. And you have a button on your calculator that would change that to a fraction. So this would be a much better way to represent our answer than a decimal answer. All the other decimals that we've had for our answer today were not repeating decimals. It was just a big long decimal. It kept on going on forever, kind of like pi. Okay, this is not that case. 1/3 is is a fraction. So my only answer. Okay, and I know it's been a couple of days since we talked about these rules, so we're going to kind of refresh our memory about the log rules that we did on Friday. Friday was kind of a different lesson because we really were just talking about how to rewrite and use all of the log rules or properties. In order to do these properties or rules, the base has to be the same. So in this case, the first thing we notice is that they both have a base of 2, so that's something that we know that we can do. But I want to get this into one single log. Right now it's 2 separate logs. I want to combine those together to get into a single log. And so we did a lot of problems on Friday where we said, combine this together into a single log. That was one of the ways that we expressed it. Because these have the same base, we can do that. When there is a plus sign in between, what are we going to do with those 2 expressions? Multiply them, okay? So this would be the log base 2 of x plus 1 times x minus 1 equals 3. I don't need to do anything with the right-hand side. What we've done here is we've combined the 2 logs into one. So now we have just a single log in our equation. What do you think we're going to do with these 2 expressions? Yeah, just FOIL it, okay? It's just good old FOIL. And you could have done that right away if you wanted to. I'm just rewriting it so you can see that. So we have log base 2 of x squared minus 1 equals 3. Okay, because it's dots, right? The 2 inside terms are going to cancel out, so that's why we don't have a middle term when we FOIL there. The positive 1x and the negative 1x would disappear. All right, so what we're going to do is change this, just like we did on a couple other problems today. Because this is a log equation, we're going to change it into an exponential equation so that we can solve for x. X squared minus 1 equals 2 cubed. 2 cubed is really 8. Then I could add 1, trying to get x by itself, right? What would be the value of x here?
3
Okay,
plus or minus.
plus or minus 3. Good. Okay, so we would say plus or minus 3 because it's x squared. 3 times 3 is 9. Negative 3 times negative 3 is also 9. So there's 2 different possible answers here, positive 3 or negative 3. Now here's where we're going to have to be careful, okay? As I go back to my original equation, especially when we have a log equation like this, we're going to have to check our answer, okay? When I take a positive 3 and plug it in here, 3 plus 1 is 4, 3 minus 1 is 2, okay? So this is log 4 base 2, log 2 base 2. If I have log 4 base 2, 2 to what power gets me 4? 2. So this whole expression would become 2. Log 2 base 2 would just become 1. 2 plus 1 equals 3. Okay, it checks out. But here's where the other one you have to be careful of, negative 3. If I put negative 3 in right here, negative 3 plus 1 is a negative 2. What happens when I take the log of a negative number? Can't do it, right? One of the things that we talked about when we first started talking about logs is we can never ever take the log of a negative number. When I plug negative 3 in, back right here or here, either one of those, I'm going to have a log of a negative. I can't do that, okay? So I cannot take the log of a negative. Here is x equals 3. All right. So what we'll do is, I know we're getting close on time here. We'll finish up this lesson tomorrow. I'll give you the